welcome to my YouTube channel. To all of you, my returning subscribers, thank you very much for your support. You guys are awesome. And if you are dropping by for the first time, please like this video, hit the subscribe button and strike the bell notification. That way, you will be the first to know anytime I post new content. Thank you very much as you do so. So in this week's video, we'll continue our conversation about AWS security, and we're going to start with looking at the core concepts of IAM. We're going to be looking at users, we'll look at user groups, we'll talk about roles, and then we're going to be moving on to look at policies. We'll define what policies are. We'll look at the different kinds of policies, like identity-based policies and resource-based policies. And then we are going to be talking about permission boundaries. We'll see how permission boundaries work. And then we'll get into the console, and then we'll begin to distill all of these things to see how all of it comes together. So stay on. This promises to be a very, very educative session. Thank you very much as you do so. So in this video, we will be discussing AWS security. We are going to be looking at IAM security principles, policies, and permission boundaries. So let's get started. By way of an agenda, that's what we're going to be talking about. We'll talk about identity and access management, or IAM. We'll talk about security principles, policies, permission boundaries. Then we'll do a summary of all what we've talked about, and then we will conclude. So let's get started with IAM. Now, AWS Identity and Access Management, or IAM, is an important component of AWS security. And that's because it provides the tools to manage and access the AWS services, and to do that securely. Now, with AWS, you can control who is authenticated, that is who is signed in, and who is authorized, that is who has permission to use resources. It is a global service. What that means is it operates across all AWS regions, providing you with a centralized way of managing access to all of the AWS resources, and also allowing you to manage users, groups, roles, and policies from a single global interface. It also lets you set up granular permissions and apply them to different users, to groups, roles, and resources. And that's going to be ensuring that only the appropriate people have the right level of access to your AWS environment. So, if you leverage IAM features such as multi-factor authentication and policy conditions, then you can enhance the security posture of your AWS account. Further, it has the ability to integrate with corporate directories and use role-based access controls to simplify identity management across the organization. And there is support for the use of temporary credentials, which can be especially useful for scenarios that require short-term access or for applications that run on AWS. We can see that IAM is important, and it is, in fact, the cornerstone of security within the AWS ecosystem. And that's because it gives a framework for managing user access and permissions. And that's going to be ensuring that only authorized users can interact with specific resources. So you can do this by applying fine-grained permissions, and then that will allow you to control the level of access that is granted to users, to roles and groups. And it's also going to be minimizing the risk of unauthorized access. And there is also support for what is called ABAC, or attribute-based access control, which allows for scalability and flexibility in permission management. That is especially important for organizations that need to manage access across multiple AWS accounts and applications. IAM allows for the establishment of organizational-wide guardrails. And these guardrails act as preventative measures to enforce security policies automatically. And there's also the facilitation of the possibility of enforcing least privilege, ensuring that users have only the permissions that they need to be able to perform their task, which, of course, is the best practice within security environments. So this approach is going to now be enhancing security and then streamlining the process of verifying and right-sizing permissions which is going to be making it easier for organizations to manage their cloud environment securely and effectively. So let's look at some of these entities within AWS IAM. We're going to be beginning with defining the broad entities, and then we'll get to the specifics. For example, we'll start with security principles. Now, security principles form an important aspect of the architecture of security within any cloud environment. And these principles includes users, groups, roles, and we are going to be using all of these entities to manage access permissions effectively. So, what are users? In AWS, users are individual entities. These entities can be associated with actual people, such as employees. They could also be associated with service accounts or even with external partners. Every user would have unique credentials and permissions, and these permissions will be determining the scope of their access within the AWS environment. Groups, on the other hand, are collections of users that share similar access permissions. So, by assigning users to groups, administrators can streamline the permission management process, as any permission changes to the group will automatically be applicable to all of the users within that group. And of course, in the process of doing that, administrators will be streamlining the process of making assignments and access control easier for multiple users by simply adding them into the group. Now, another important security principle is the role. A role in AWS serves a slightly different purpose. That is, they are used to grant specific permissions to AWS resources or to users from other AWS accounts. Now, unlike users, roles do not have standard long-term credentials, such as passwords or access keys. Rather, when a role is assumed, temporary credentials are dynamically generated. This can be especially important within scenarios where cross-account access is important, or when we are integrating third-party services that require certain AWS permissions. Now, the use of roles also will be adhering to the principle of least privilege. And that's going to be ensuring that entities are granted only the permissions that they need to be able to perform the intended tasks. For example, we may have a Lambda function. So roles will be very important here because they are going to be granting necessary permissions for the function to be able to interact with other AWS services. In the same vein, we could also have EC2 instances, and these instances will require roles to allow applications that are running on those instances to be able to access AWS resources securely. So by assigning specific roles to these services, administrators can ensure that each component have only the permissions that are needed to perform specific tasks, also adhering to the principle of least privilege. And this control is very, very important, specifically in multi-user environments where tasks are distributed across various services, making roles an important aspect of the security strategy within AWS. Next, we are going to be looking at policies. Now, policies are also a very crucial component of AWS security. That is because they provide fine-grained control over AWS resources. Now, policies enable administrators to specify precisely who is authorized and to grant them access to resources and how they can interact with those resources. So, these policies basically are defined as JSON or JavaScript object notation for documents, and they will consist of statements. And some of these statements includes things like the effect, the action, the resource, and the condition. Now, the effect is going to be specifying whether the policy allows or denies access. Action is going to be defining the operations that can be performed. Resource will identify the AWS resource, and then condition is going to be providing context for when the policy should be applicable. Now, by using IAM policies, organizations can enforce their security requirements, and they can do that consistently across all access methods. And that's going to be ensuring that users have the appropriate permissions to be able to perform their task without compromising the security of AWS resources. So let's look at a policy example. Now, we see a policy example here on our screen here, and this basically is the policy that has been applicable or has been applied to the administrator access permission here. And now this policy grants full access to all actions and all resources. We're going to distill this, just take a minute to distill this. First, we can see that what we referred to in the previous slide comes to play here. First, we have the first aspect of the policy, which is the version. Now, the version line refers to the policy language version, which in this case is the date when the policy language was last updated. And then we have another section called statement. Now, the statement section contains an array of individual statements. In this case, it contains only one. The statement has an effect of allow, which means that the specified permission is the allow permission. And then it also has another component called action. Now, action here, we can see that the action has a star, which is a wildcard. The star indicates that all of the actions are allowed. And we can also see another component, which is the resource, which also has a star, meaning that all of the permission, meaning that the permission applies to all of the resources. Now, this type of policy should be used with extreme caution. That is because it allows anyone that this policy has been applied to perform any action on any resource within the AWS account. And while this might sound convenient, this could lead to potential security issues if it is not appropriately managed. Again, generally, the recommendation is to follow the principle of least privilege, and that means granting only the permissions that are required to perform any task or any the necessary task that the user should be able to perform. So let's look at the different types of policies. Now, there are several types of policies in AWS IAM, and each of them have specific purposes. For example, we've got identity-based policies that are attached to IAM identities, such as users and groups. We've got the resource-based policies that are directly attached to resources, such as S3 buckets or IAM roles, for example. We've got permission boundaries, which will be setting the maximum permission that can be granted to an IAM entity. We also have organization service control policies that will be defining the maximum permission for members within an organization. We have others like access control lists. And of course, we also have session policies that's going to be granting permissions for particular sessions when assuming a role or federating a user. Now, it's important to understand these policies and to understand how these policies will be applied. And that is going to be allowing you to properly secure your AWS resources. So let's go into some more depth into two types of policies. We are going to be starting with the identity-based policies. Now, identity-based policies allow for granular control over the permission that is granted to identities, such as users and groups, for example. Like we said earlier on, and we saw in the policy example, identity-based policies are also defined as JSON documents. And these documents will clearly define the actions that are allowed or the actions that are denied across various AWS services. For example, an identity-based policy can be created to permit a user to perform actions on S3 buckets, such as, for example, retrieving and storing data or objects more appropriately within the S3 buckets. Conversely, the same policy can restrict that user from accessing EC2 instances. And that's going to ensure that they cannot start or stop servers, they cannot modify instances or access the associated storage. Now, this level of specificity in permission setting will allow organizations and administrators to enforce the principle of least privilege. And that's going to be ensuring that identities have only the permissions that they need to be able to perform the task that they should perform. Now, through the use of these policies, we can manage access rights, we can reduce the risk of unauthorized action, and of course, we can overall maintain the proper security posture within the AWS environment. The next kind of policy we'll talk about are the resource-based policies. Now, unlike the identity-based policies that are attached to AWS identities, resource-based policies are used to manage access to services and resources within AWS. Now, the policies or these policies are directly attached to the resources themselves rather than to the IAM users or groups. What this means is that the policy controls access to that specific resource, regardless of who the request comes from, and can be applied to a wide range of AWS resources, such as S3 buckets, for example. Now, a resource-based policy on an S3 bucket can specify who is allowed to read files from that bucket or write files to the bucket. Now, this level of control can be especially important when we want to grant access to users from outside of our AWS account, such as maybe third-party services or third-party contractors. The policies are also defined in JSON format, and we could create policies that grant read-only access, for example, to a specific S3 bucket. And that's going to be ensuring that users can view and download files, but cannot modify or delete those files. And this, of course, can be very important for the purposes of data integrity maintenance and security, especially when we are dealing with sensitive documents. Now, let's look at permission boundaries. Now, permission boundaries are a means to set the maximum permission that IAM and entities such as users and roles can have. This is going to be limiting the permissions that are granted to these entities to the least privilege necessary to perform their tasks. Permission boundaries are very useful in preventing over-permissioning of IAM entities, and which this over-permissioning can lead to potential security risk if it is not appropriately managed. So by defining permission boundaries for specific IAM policies, organizations can ensure that their IAM entities operate within a predefined scope of permissions. And that is going to be helping them to mitigate the risk of unauthorized access or unauthorized actions. Now, the use of permission policies or permission boundaries, I beg your pardon, allows administrators to delegate certain permission management tasks to other IAM users without relinquishing full control. Now, this delegation is done within the confines of permission boundaries, which is going to be ensuring that the delegated permissions cannot exceed the boundaries that are set by the administrator. And this is going to be facilitating a more distributed approach to permission management, which will in turn be allowing for greater flexibility and greater efficiency while we are still maintaining a strong security posture. So, wrapping everything up, we're just going to summarize some of the things we have done. Now, the first thing we talked about was users. And we said users are individual accounts, which will typically have a combination of usernames and passwords. For example, we would have a user called John Doe, and the username could be John.Doe, for example. And then we also have groups. And groups basically are collections of users that have similar permissions, and will typically be grouping users by function within the organization. So we can have developers, we can have auditors, we can have admin groups, for example. And then we've got roles. And these roles basically are sets of permissions to be assumed by entities that you trust. So we can have roles like, for example, the EC2 read-only role and the Lambda execution role, for example. And then we can have policies. And policies basically are documents that define permissions. Example, we could have policies like the Amazon S3 full access policy or the EC2 full access policy, for example. And then we've got permissions. Permissions define the exact level of access that is granted to users, groups, or roles. And then there are relationships between all of this. For example, users can be parts of groups. Groups, policies can be attached to groups. Users or services can assume roles, and roles can equally have policies attached to them as well. And these policies will be dictating the permissions that all of these entities will have. So what are the final thoughts? Well, we are going to be moving into the console. We are going to be practicalizing all of the things that we've done And then, of course, we are going to be explaining these things further with practical examples and tests. So please stay with us and watch on. Thank you very much as you do so. All right, so we are in the AWS console, and we want to begin to uh, see the practical aspect of some of the things we discussed earlier on in this video. So the first thing I want to do is I want to get into the IAM console. I'm currently on the console home for AWS, but I want to get into the IAM console. And there are a number of ways I can do that. Of course, we can see here that I have visited the IAM console a number of times. So it's listed here as the one of the recently visited consoles here. So I could just go and click here. That's one way. The other way it will be to click on services, and also I have the IAM listed as one of the recently visited services. But for this particular demonstration, I want to do a search. So I'll go ahead and click on IAM, and I'll just click on enter, and that takes me to the IAM console, starting from the dashboard. So we can see a lot of things going on here. We can see some of the resources I have. I have one user groups, two users, a number of roles, a number of policies. Okay, so those are some of the things that we can do in IAM. Now, another thing we want to point out here is that IAM is a global service. So if you click down here on this drop down, you see that we do not have any of the regions available for selection. And the reason is simple. The reason is that IAM is a global service. And that basically means that if we create one of the identities or create an entity in IAM in in our console there, it will replicate to all of the regions or all of the servers that are available supporting the IAM service. So basically, you can create it once and it becomes available globally. It may not be available immediately we create it, but it will be eventually available because the IAM service is an eventually consistent service. So we're going to be doing a number of things. First, let's go to users and let's go and see how many users we've got. Currently, I've got 2 users. And we can identify users in a number of ways. One way is we can identify the user by username. In this case, we have a friendly name that we should be able to remember. And the other way we can identify a user will be through the ARN. That is the AWS resource name here. So the AWS resource name has got a format. We see here, we've got the ARN, we've got a colon, AWS, a colon, IAM, identifying it as an IAM entity, and we have 2 columns. Then we have the account ID, and then we've got a column, we've got the user, and then of course we've got the username here. Okay, so now that we know some of the basics, we can go ahead and create a user. To do that, I'll just click on users. I'll go to create user. I'll specify a username following the conditions for naming a user. It tells you that the user can have up to 60, a username can have up to 64 characters, telling you the valid characters and all of that. So I have the valid character, and then optionally it prompts you to provide user access to the AWS Management Console. I'm not going to be doing that right away. I'll just go ahead and click on next. And the next thing it does is it gives me a number of things I can do. I can add a user to a group in one go. I can copy permissions, or I can attach policies. And right here, it even gives me the option to create a group. But this case, of course, I want to go ahead and add users to a group. And I'll just have the option of maybe adding the user to the administrator. But of course, when you are adding a user to a group, you've got to be very, very careful, always taking note of the principle of least privilege. So for here, I want to just do a search here and see all of the possible things I can do. Okay, so there's just one group available here. And then, of course, I can actually go ahead and create a group in this scenario. So I'll go ahead and click on create group, and see it gives me I can create the group, and it gives me a set of policies that I can attach to the group. And a lot of the policies here are AWS managed policies. So I just go ahead and look for something that is EC2 related. Just type on EC2 and let's see what we've got. Sorry, I should search here rather. Okay, so we can see we have all of the EC2 related permission policies here. So I want to maybe make this group an EC2 read-only access group. That's I want to assign the policy to it. So I'll go ahead and click on create the user group. I called my user group EC2, and then of course the attached policy there is the EC2 read-only access policy. So I now go ahead and add my user to that group, and then I'll go ahead and click on next. So it gives me all of the details. It gives me a review. It tells me the details, the permission summaries, and it gives me tags which are optional. Now, tags, while they are optional, they can become very useful because they allow you to identify whatever resource you are creating within the AWS service. So you can have up to 50 tags per resource or per entity. To just create a tag, you just go ahead and click on add new tag. But for the purposes of this demonstration, I want to keep it simple, and then I'll go ahead and click on create user. And we can now see that while I had 2 users before, I now have a third user, which is the test underscore user. And if we scroll down, we can see that the user 2 has an ARN, which is similar to the ones that we had before. So that's simple. That's how to create a user. And in this scenario, we created the user, we created the group, and then of course we assigned the user to the group, and we did that in one go. So we are going to be moving on to the next step, and then we are going to continue to demonstrate some of the things that we discussed earlier on. So the next thing we want to do is we want to create groups, and very similar to how we created users, we'll go ahead and click on user groups in the IAM console. And like we did in the last time, you see we created the EC2 group at the point where we're creating a user. And of course, we already had an admin group. So we've got 2 groups. Now, what we want to do is we want to go ahead and create a third group. So I'll go ahead and click on create groups. And we see here that while the IAM user had a maximum of 64 characters, the IAM groups has a maximum of 128 characters. So we'll go ahead and call this group, maybe we'll call it S3, for example, full access, for example. So we have a group name, and just like we were able to add a user to a group immediately when we're creating the user, we also have the option to add users to a group that we are creating already. So in this case, I don't want to do that just yet. And we have a list of all of the permissions that we can attach, all the permission policies we can attach. In this case, I want to search for an S3 related permission policy. So it gives us a number of things that we can do. We have S3 read-only access, AWS service role policy for S3 backup, S3 restore, and all of those kinds of things. But of course, since I want an S3 full access, I'll go ahead and click on S3 full access, and it goes ahead to attach the permission. And then I'll go ahead and click on create user group. And we can see here that we have the S3 full access group, which I have created. But you are going to take note that since I did not add any group to any user to the S3 full access group, it currently tells me that there are no users here. So that now takes me to the next thing I want to do. I want to now go back and add a user to that group, to the group that I have created. So I can go ahead and let's quickly see what's going on here. So I select the group, that's the S3 full access group. It gives me the name, it gives me the details, it also gives me the ARN, similar to what we had for the ARN of the user. In this case, the difference being that while the previous ARNs identified the entity as a user, this one identifies it as a group. So we have the colon group after the account ID identifying this as a group, and it gives us a slash, and then it gives us the group name. So I want to go ahead now, and we also have the option of looking at the permissions, and it tells us the policy that has been attached to it. And then of course we want to go ahead and look at when it was last accessed. Currently we've not, okay, it tells us this detail here, it tells us the allowed services and all of that. And but what I want to do is I want to go ahead and add a user to the S3 full access group. So I'll go ahead and click on add user, and this is the user I created. But note that I can add multiple users to the group in one go. Okay, so to do that, I'll just go ahead and select all of the users, but in this case I want to add the test user only. So I'll go ahead and click on add users, and if we go back to the user group now, I'll go ahead and select the user group. If I go ahead and select this now, we can see that we have one user now attached to the group, and that user is the test user. So that's how we create a group. And of course, we are going to continue to demonstrate other aspects of the video to see how we can do all other things. All right, we've seen how to add users to a group. We could also remove users in a group. To do that, we'll go ahead and go to the user group, and then we can see the group list. And we have been working with the S3 full access group. So I'll click on it, and we can see here that we have two users. To remove a user, I can just go ahead and select the user, and then I'll go ahead and click on remove, and it tells me that this user will lose the group permissions. I'll go ahead and click on remove, and we can see that previously we had two users there, but now we have one user because we've removed excuse me, the second user from the group. Now, other things we can do is we can go ahead and do some editing on the group. For example, I want to maybe go to this group, and I can do some editing. For example, I want to rename the group. I'll go ahead and click on edit, and it prompts me. I could just call it EC2 group. I'll just make an edit, see, and again I'll go ahead and click on save changes. And while our group was called EC2 before, we now have renamed it to EC2 groups. Now, another thing we can do is we can, as part of the editing, we can delete a group. So I'll just go ahead and select the group, and then I'll just go ahead and click on delete. It prompts me that I need to confirm the deletion. I've got to type the name of the group. I'll just go ahead and copy this, and then I'll paste it in that dialog box there, and I'll go ahead and click on delete. Of course, it tells you that it's going to delete this permanently. The action cannot be undone, and I'll go ahead and say, okay, I'm convinced I want to delete the group. I'll go ahead and click on delete. And if I come to user groups again and I do a refresh, we can see that while we have three groups, I have taken one out and that group has been deleted. But take note of this. If I assign users permissions by adding them to the group and I delete the group, it does not delete the users. However, if I had policies that I bound to the group and the users inherited the permissions as a result of being a member of that group that that policy is bound to, what that means is that they now lose the permissions they had because the group is no longer there, and therefore they are no longer members. So we'll continue to do some additional stuff as we move on. I think the next thing we'll be talking about roles. So we have been talking about different kinds of IAM identities. We've talked about users, we've talked about groups. The next thing we will be discussing, we'll be looking at IAM roles. So what are they? IAM roles are also uh, a type of IAM identity which you will be creating in your account, and this will also be having specific permissions. Now, it's similar to IAM users and user groups in that it is an identity, and you will also have permission policies that will be determining what the identity should be able to do in your AWS account. But unlike AWS users, instead of being associated with a single person, a role is actually what is intended to be assumable. And anyone that needs to use the role can assume the role. And also, the role does not have a standard long term security permissions. Instead, when you assume a role, it's going to give you a temporary security credentials for that session. So, what that means is, unlike the users, you will not have a password or even a username associated with the role. So what you will be doing with a role is you'll be using it to delegate access to users, to applications or services, especially when these services don't normally have access to any of your AWS resources. For example, you might want to grant users in your account access to resources that they usually do not have, or you want to grant access to users in your AWS account and you want them to be able to do specific things. So let's go ahead and create the role. So we are in the AWS IAM access, that's IAM console. I'll go ahead and click on roles to start the process of role creation. Now we see here that I already have a number of roles, but of course, like I would create any other IAM identity, I'll go ahead and click on create role. Now we can see here that we have a number of trusted entity types that we can use. We can create a trusted entity type of AWS service, AWS account, web identity, SAML federation, and custom trust policies. But for the purposes of this demonstration, I want to create a role for an IAM user. So I'll go ahead and click on AWS account. Now, when I create an AWS account, it gives me a description here. It says it allows entities in other AWS accounts belonging to you or third parties to perform actions in this account. So, but for this scenario here, I want to create the role for this account. But you can see that I have options to create it in another account, and I also have options to require external IDs and require multi-factor authentication. But I'm going to keep this simple. I just want to create an AWS, create a role in this account. So I want to go ahead and click on next. Now, clicking on next here, it gives me a specific list of permission policies. And in this case, of course, let's go ahead and look for an EC2 related policy which I want to attach to the role. So we have one here, which is the Amazon EC2 full access policy. And if I expand on the policy, we can see what the policy can do. We can see the version, we can see the statements, action, effect, and resource. So we see, for example, EC2 allow for all of the resources, and there are a number of them here. I'll just go ahead and attach that. So I'll go ahead and click on next, and it prompts me to give my role a name. So I'll go ahead and give it a name. I'll call it full access for EC2, for example. and I can give it a description, though not entirely compulsory. I usually, as a best practice, would like to give it a description. So I'll say this role allows identities that assume it to have full EC2 access. Okay, so I still have options to select the trusted entities, add permissions, and to specify tags. I just go ahead and create the role, and that's all it takes. We can see that we now have the full access for EC2 role, and that's what it takes to create the role. So the next thing we want to do is we want to go ahead and see how we can assume the role and see the kinds of things that we are going to experience should we assume the role. All right, so we have created the role, and that's the role there, full access for EC2. So we want to go ahead now and test and see how role works. So first of all, go back to the user we created at the beginning, that is the test user. And I want to go ahead and do a number of things that will allow us to use that user to test how to assume the role. So the first thing is I want to go ahead and enable console access for the user. Enabling console access for the user would allow the user to log into the AWS Management Console, where I'm before, and then while I'm enabling the console access, I'm going to assign the user a password that I'm going to use to test. So basically what I intend to do is this. I'll log in as the user. Remember that this user has a particular set of permissions, and that is the Amazon S3 full access and nothing else. And also remember that the role that we've created has full EC2 access. So we are going to log into the user, the test user, see the kind of access we have, and then we are going to assume the role and then try to see if we are going to be having some additional permissions to be able to do EC2 related things. So let's go and create or enable console access for this user. So I'll go ahead and enable console access, and it prompts me to specify a number of things. I want to go ahead and specify custom passwords. So I'll go ahead and specify a password which I'm going to use to log into, and I don't want the user to create a new password at next login, but of course that is not best practice. I'm just doing that here purely for demonstration purposes. In real life, you want to be sure that user must create new password at next sign in is checked. What that means is that even you, the administrator, should not have access to whatever user you have created. So I'll go ahead and enable console access, and it gives me the console sign-in URL, which I'm going to also copy, and of course it gives me the test username, and then I'll go ahead and close. So I have created the user. I've enabled the user for console access, but there's one more thing I need to do in order to be able to allow the user to assume the role that I have created, and that is I need to attach a policy that grants the user the STS assume role to the specific resource, which is the full access for EC2 resource that I created. Now that way the user will have the permission to be able to assume the role, so that when we go to test we are not going to encounter any surprises. So back to the user the IAM console. In the users section, I'll go ahead and select the user. So I have selected the user and it opens the permissions tab by default. So I want to go ahead and add a permission. This time around, I want to attach the permission directly to the user. So in that case, I want to create an inline policy. So I'll go ahead and select that. So I create the inline policy, and I just basically go straight to JSON because we've been looking at other methods of creating policies. So let's see how we can do that using JSON. So in JSON, I'll just go ahead and select everything in the policy editor and delete it. And then I had created a policy, and that's basically what the policy looks like. So looking at the policy, we see the version, we see the statement, we see the effect, we see the action, and that's where we are very interested. The STS assume role is the action, and this is the resource here, which is the EC2 uh, full access for EC2 role that we created. So that's the resource there, and that's basically it. If I go back to visual, we can see that it gives me all of the details of what I want. I could have as well done it here, but I just wanted to demonstrate how to use JSON to create the policy. So I'll go ahead and click on next, and I'll give my policy a name. I'll just call it allow assume role with STS, just to give it a specific and descriptive name. So I'll go ahead and click on create policy. So it tells me, see, we can see here now that we have the policy that we have created, and we are now ready to get into the AWS console and assume the role and see the kinds of effects that that's going to give us. So let's stay tuned. So I have launched an in private browsing window here, and I want to sign in as the test user. So I'll go ahead and select test user as my username. I'll go ahead and enter the password, and I want to sign in. So it signs me in. We can see here that lots and lots of things are disabled here. Remember, the permission here is S3 full access. So it allows me to do everything S3 related. If I were to, for example, come to create a bucket, it gives me all of the permissions to do so. But if I try to do anything else, for example, I want to go to EC2. See, we have API errors everywhere because each time you try to do something within the AWS console, you're actually calling an API. So let's try to, for sake of argument, try to launch an instance. Let's see. I try to, for example, it's still loading. I try to select an instance type of T2 micro. I see it doesn't allow me to select a key pair. It doesn't allow me to do a lot of things. And even if I were to say, okay, I want to stubbornly launch an instance, it tells me that I can't proceed with a key pair. It does not allow me to select a VPC. It does not allow me to assign a public IP. Lots and lots of things cannot work here in this case because of the permission that I have. So now, I want to now try to, well, assume the role, and I'll show you how to do that in a minute. So we'll come here to where we have the username. Remember, I'm signing as a test user. I'll come here and I want to switch role. Okay, so it prompts me to put in the account ID, which I will put. It prompts me to put the IAM role name, which I'll also include. And the display name is optional. So let's see what happens if I do a switch role. So we see back to the same place where I could not do anything. We can see now that if I were to, for example, try to create an EC2 instance. Let's call it my role instance. And we see that all of the errors have magically gone away. So I can specify the T2 micro, I can select a key pair, or at least create a key pair, or I could even proceed without a key pair, which is not recommended. I can, for example, select a security group, and I can do a whole lot of things that I couldn't do before because I now have the EC2 full access role, which I switched to. So if while still holding on to this role, let's see if I can do anything S3 related, which is the permission that the user account has originally. So let's see if I can create a bucket, and apparently it does allow me to do that in addition to the role that I am holding. So I can do that as well. So basically that's how this works. If I want to switch back to my normal access, we can see here, I can just go back and say, okay, I want to switch back. And once I'm able to switch back, if I go back to the EC2 instances, of course, we see the errors come back again. So that's basically how we can switch EC2, can switch roles to allow us to perform some additional actions if we do not originally have that permission that is bound to our user access. So the next thing we will be demonstrating and talking about are permission boundaries. Okay, so we'll be discussing permission boundaries. Now, AWS has support for permission boundaries, and these permission boundaries can be applied to IAM entities such as users and also roles. Now, permission boundary is a very interesting feature, and we can use it to specify managed policies that sets the highest level of permission that an identity-based policy can grant to an IAM entity. So the permission for the entity through permission boundaries will allow it to perform only the actions that has been allowed both by its identity-based policy and its permission boundary. And we'll typically be using managed policies or a customer managed policy in order to set the permission boundaries for an IAM entity. And what the policy does is it's going to limit the maximum permission for the user. So let's go ahead and first of all create a user and try to demonstrate this. So I'll go ahead and create a user. I'll go to users. I'll go to create a user, which I'm going to call super user, for example, and I want to click on next. Now here I want to add the user to this administrator group, and the admin access basically gives the user super user access into the AWS console. So I've done that, but further I want to now say, okay, I want to use permission boundaries to control the maximum permission. So I want to select, in this case, one of the AWS managed policies that I want to use to now limit the kind of permission that this user called super user will be able to have access to. So I'll go ahead and select this checkbox. And here, let's say I want the user, while the user is originally assigned the admin level permissions, I want the user to only be able to do VPC related stuff only. So I'll just select VPC here, and I want to now grant the user Amazon VPC full access only. So if I expand the policy here and we look at the permissions, we can see that the user can, of course, do everything that is VPC related, can accept pairing connections, can accept endpoint connections, can do a lot of VPC related things. So on the one hand, while the user has full admin permissions, I have used permission boundaries to control just how much the person can do. So I'll go ahead and click on next. And that's basically it. I will have created the user, assigned the user to a group, which is the administrators group. And I have also used permission boundaries to limit what the user can gain access to. So I'll go ahead and create the user. So it creates the user here, super access. So I'll go ahead and this time around, like I did before, I want to go ahead and give the user console access. I'll create a custom password. And I want to enable console access for the user. And then we are going to log in to console and see exactly what is going to happen. So let's see. So we are in an in-private browsing window. So I'll go ahead and specify the username. And then I'll specify the password. And let's sign in and see. So ideally, since the user is a member of the admin group, all of this, we shouldn't have any access denied errors here. But let's try and see if the user can do anything other than creates VPC related stuff. So I'll go to S3. And let's try to create the bucket. Let's just I just go ahead and accept the defaults. And we see here that you fail, it gives us an error that failed to create bucket. It tells you that you need the S3 create bucket permission required. So why has this happened? It has happened because while the user is a member of the administrators group that basically gives the user access to everything, we have limited what the user can do through the use of permission boundaries, where we specify that the user, even though is a member of the admin group, should only be able to do VPC related activities. So that's basically how permission boundaries work. And if we now go ahead to go to the VPC console, we should see that we will not see any of such errors available for the user because the permission boundary is working in line with the admin permissions. So the user should be able to create a VPC related resources in AWS. So we don't have any errors here at all. And that is because of the permission boundaries that we have established. Okay, all the while we've been discussing different kinds of policies, and we said that a policy is an object in AWS, and if we associate it with an identity or even with a resource, it's going to be defining the permissions. Now, when we create a permission policy to restrict access to a resource, we have the option of choosing between an identity-based policy and a resource-based policy. All the while we've been discussing and demonstrating on identity-based policies, we are going to now begin to talk about resource-based policies. So what are resource-based policies? Basically, resource-based policies are attached to resources. For example, we are going to be demonstrating how to attach a resource-based policy to an S3 bucket. But apart from S3 buckets, you can attach resource-based policies to SQS queues, to VPC endpoints, to KMS encryption keys, to DynamoDB tables, and many, many, many others. So we are going to be looking at how to attach a policy to an S3 bucket. So I'll go to the S3 console. We had created an S3 bucket already. So I'll go to the S3 console, and that's our bucket there. I'll go ahead and select the bucket. So we can see our bucket, there's no content in the bucket. I'll go ahead and click on the permissions tab, and I'll scroll down to the bucket policy, and then I'll go ahead and click on edit. Now, editing here gives us a blank canvas, nothing. We want to define the policies. That's our AWS resource name here, which is the name of our S3 bucket. So we have a number of options which we can use. We have the policy generator, which is this. We can actually come and specify the type of policy, add the statement, specify the service, the actions, the Amazon resource name, and then we can go ahead and generate the policy. Now, the other way would be to go ahead and see some policy examples from the AWS S3 documentation. So we have a lot of example bucket policies here. For example, we have policies that can grant read-only access to an anonymous user, which we see here. They are all defined as JSON. So this requires server-side encryption KMS for all objects that are written to the bucket. But we can just scroll down and get to a specific one that we want to use. So I'll go all the way down to the very last policy, and then we are going to be playing with that. So what this policy does here is we want to explicitly deny delete object permission to a user. So I'll go ahead and copy this, and then I'll come here and paste it. But of course, there are a number of things I want to change. So I'll come here and, for example, for the resource, I'll come and specify the name of my bucket here, and I'll specify the name also here. I'll just go, and then I want to here specify the IAM user, but before that I'll come here and specify the ARN again, and here, and this is where I want to specify the IAM user. So I'll go ahead and specify the IAM user. And then, of course, the user will be the test user we created. Okay, and I am ready to roll. So if I've specified all of that, I can just go ahead and save the changes. It tells me, of course, sometimes it tells you there is an error. You have to now go ahead and check out the error. In this case, it's telling me invalid principal in the policy. So I have to go ahead and check the principal. Okay, and let's see if we can make the correction and then move on from there. So this is not a proper principal. I have to go ahead and get the appropriate principal name, which I'm going to do in a minute. I'll just come here, open in the new tab, go to IAM, select the user, and I'll just come here and copy this. And copy here too. This is likely where that error came from. Okay, and let's go ahead and be sure that we have everything ready. So I'll go ahead and click on Save Changes, and we have successfully edited the bucket policy. So now we've assigned a resource-based policy to our bucket, and of course that is going to be uh, only allowing the things we have specified in the policy. So that's all we've got for today. Thank you very much for staying up till the end, and see you in the next one.